Let's talk about some absolute value inequalities, okay? Absolute value inequalities are a special set of inequalities because you've got to pay attention to these inequalities are actually going to break up into two inequalities, and they're either going to be joined with and or with or, and that will depend then on how you look at your answer set in the interval. So let's go ahead and jump right into it. I'm going to bounce down to problem number 1 here. We've got the absolute value of 2x minus 1 is less than or equal to 7. This inequality symbol, the less than portion, is going to tell you what kind of inequality that you are dealing with, whether it's an and or an or. As goofy as this sounds, okay, this is one of the best ways I have found to remember it. Less than, again, I know that sounds kind of goofy, or it's great or. Okay, so if you can remember less than or greater, and sometimes you'll even hear me when I say it, I stress the or part of greater to remind myself that it's an or combination, or with less than, it's and to combine my two inequalities. So when you write this, you're going to take this inequality and just write it the first time as 2x minus 1 is less than or equal to 7. Just straightforward, drop the absolute value bars, okay? This is less than, so I'm going to put and. Your second inequality, you are going to leave this first part alone, so it's 2x minus 1, and now you're going to flip the inequality and take the opposite of this number. So as I fling the page around, sorry about that, we're going to go ahead and do greater than or equal to negative 7. Now that the absolute value bars are gone, we can just solve these two inequalities on their own, okay? So I'm going to add 1 to both sides here. So 2x is less than or equal to 8. I'm going to divide by 2. I'm dividing by a positive, so there's no need to switch the signs of anything. Separately, I'm going to go ahead and add 1 here and here. So let's see, 2x is greater than or equal to negative 6. I'm going to divide by a positive 2. So again, no need to change the sign. So one of the things to be careful about is it doesn't matter that the negative 6 is negative. It matters that you are dividing by a positive. So dividing by a positive has no impact on this inequality symbol. So leave it as, in this case, greater than or equal to. And what joins them is the word and. So this is the simplified version of our absolute value. Because it's and, both of these inequalities have to be true at the same time. So how do you find that? Well, a couple of methods. One method is to graph the two inequalities together. And what I'm going to do is I'm actually change colors here. And let's see if I can make this work. Okay, so this says x is less than or equal to 4. So from 4, things that are less than that would be to the left. Okay, so I'm shading all the way to the left. Separately, if I look at this inequality, it says x is greater than or equal to negative 3. So I'm going to start at negative 3 and shade to the right. Now, it's hard to see it. I tried to pick two colors that would work, but what you want to look for is this purple overlap in the middle. So I had red shading and I had blue shading. The purple is where both of them are shaded. And both of these take brackets because of the equal to part. So the only values that work to make this inequality true are the numbers between negative 3 and positive 4. If you pick anything outside of that, it would not work. So let's say we picked 5, for example, right? Clearly 5 is greater than 4 here. If I go back here and I put 5 in this problem, 2 times 5 is 10. 10 minus 9 is, 10 minus 1 is 9. Let me get my order right there. Absolute value of 9 is 9. But the problem is 9 is not less than or equal to 7. So that fails, right? This part up here does not work. And then if I look down here and I say, okay, let's do -4. Okay? So 2 times -4 is -8. -8 minus 1 is -9. Absolute value of -9 is +9. But again, +9 is not less than or equal to 7. So these two end pieces don't work. You want to only see the overlap for an and inequality. Okay, so anything that's less than, you need to make sure you're looking for that overlap. All right, so that's problem number 1. I'm going to slide on over to number 2 here. All right, first things first, inequality, we have less than again. So this means I am dealing with some kind of an and. All right, so first one is the easy one. You just write down what you have, no absolute value bars whatsoever. So 3x minus 7 over 2 is less than 7. And leave the expression inside the absolute value bars the same, but you're going to flip the inequality and change the sign of the 7. So we're going to go greater than -7 here. Solve both of these. So I'm going to multiply by 2, so 3x minus 7 is less than 14. I'm going to add 7 to both sides. So 3x is less than 21, x is less than 7. Okay, so that's one of them. Separately, I'm going to solve this other inequality. So 3x minus 7 is greater than -14. I'm going to add 7 to both sides. So 3x is greater than -7. Divide both sides by 3. So x is greater than -7 over 3. It is completely okay to leave that. In fact, I'd prefer that as the exact answer. All right, let's do a number line here. My critical values are -7 over 3 and +7. And the thing that joins these is and. Okay? So if it helps you, use colors, right? It's totally cool. I've got x is less than 7. So from 7, I'm going to shade to the left. Right? That's less than 7. And, let's see if I can do blue here. And x is greater than -7/3. So from -7/3, I'm going to shade to the right. So if I zoom in on the image here, again, what I'm looking for is this overlap. It's the place in this image where yellow and blue make green. That's what the answer is. Now, with this particular problem, we have less than 7, so that's going to be a parentheses here. And we have greater than -7 over 3, so that's a parentheses here. So the actual interval answer would be anything from -7 over 3 to 7, using the parentheses as the answer there. All right, so really quickly, right, start at the top. Check out your inequality sign. So this is less than, which means we're talking about and that's the and here that we're putting between our two inequalities. First inequality, just rewrite it without the absolute value bars. The second inequality, it's the same expression, but you're going to flip the inequality and take the opposite of your number. Okay, so in this case, it was less than 7, now it's greater than -7. Solve, 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 solve. Once you get down to your critical values here, graph them, look for the overlap of your graph, and that becomes the answer to this problem. All right, moving on to number 3. Okay, we're going to check out the inequality sign first. Inequality is greater. All right, so this is an OR graph. The same process, though, applies to breaking up the two inequalities. So x over 2 plus 5 is greater than or equal to 2, or x over 2 plus 5 is less than or equal to -2. Okay, so I'm going to go ahead and solve these. So let's see, x over 2, I'm going to subtract 5 from both sides, so that should be -3. Multiply everything by 2, x is greater than -6, or I'm going to solve this one. So x over 2, subtracting 5 from both sides is -7. So multiply both sides by 2. X is less than or equal to -14. Okay. So now when I graph this, my two critical values have -14 and -6. An OR graph means you are going to graph this, you are going to graph this, and your answer is anywhere that you have shading. It doesn't just have to be overlap. It's literally anywhere there is shading in your image. Okay? So if we're going to go with x is less than or equal to -14, less than 14 or -14 would be to the left. X is, did I lose an, I did. There's an equal to sign that should be following down here. Sorry about that. I just realized that. So then we also have x is greater than or equal to -6. So from -6, I'm going to shade to the right. Both of these take brackets. Okay, and the interval is all shading. So you're going to talk to me about this shading on the left, and you're going to talk to me about this shading on the right. Both of them work. So let's see, -infinity to -14, bracket, union, -6 to infinity. All right. So that's what happens if you have the greater graph. You can have shading that doesn't overlap at all, and you just write down whatever shading you do have, whatever intervals are shaded in. Okay? So these are the absolute value graphs. They're basically a two-part linear, right? Because you're just breaking up this into one linear inequality and a different linear inequality. Solve them. And then from the solve, figure out, are you dealing with and or an or graph? Okay? And again, as goofy as it sounds, if you can remember less than, and you literally, tack the A and D to the end of that, or greater, that will help you remember which inequality uses what. As always, send me any questions or concerns that you have about the material.